Oh, this is F mu n. Oh, yes. This is how basically in reality we measure this thing. F equals mu n, and this is what we measure experimentally. And remember, mu is the coefficient of friction depending on the material. Steel on steel, and steel on wood have got different coefficient of friction. I showed you a table, okay, of different materials. So how they do it? They've got body 1, they've got body 2. That's the force being applied downward. So this is how they are measuring the force. And well, forget this at the moment. So this is stationary, and then they pull it with the spring balance, kind of spring balance. And they keep on measuring this force and keeping an eye on the movement of this box. Movement of this box. So the moment it moves, this is measured, which is equal to F. And this is constant, that is the load that comes here. And that's how you can get your mu. Clear? No rocket science here.
Yes, sir.
Okay. So there's another way to experimentally determine this. And this is relatively easy. You don't need any sense or anything. It says here a block with weight W is placed on an inclined plane. So this is a box with weight W on an inclined plane. It says an angle X. The plane is slowly tilted until the block just begins to move. So I am lifting this floor. I am increasing this angle. And the moment the box moves, I record this angle. The inclination angle is noted. Analysis of the block just before it begins to move. So you've got your vertical force. This is, remember, what did I say? N is basically the normal force. So F equals, remember, F equals mu n. N is the perpendicular, is the normal force on the surface. So this is N. If I've got this surface here, then the N would be this for me. It has to be perpendicular to the surface where your friction is coming from. So anyway, let me go back. So I do analysis. Sum of all the I'm looking at this one, okay? Now sum of all the force along y-axis, which basically tells me this is that's my y-axis, and this is my x-axis. You can have your y-axis even here also if you want, but I would just simplify things. So I've got this component and component of W, that's here. And if I do sum of all the force along x-axis, I've got this component and the component of this W. That is here. You do the maths, you get this out, which is the same as this, which are exactly what mentioned before about the angle theta, which is here. Remember, inclination angle, that's what comes out. So remember, if you are given the angle of the object just before it moves, then tan of that angle is equal to your coefficient of friction. Is that clear?
Yes, sir.
Okay.
Yes.
And then we went through this. These are basically what I was saying. Cast iron on zinc will have a different coefficient of friction. You've got steel on Teflon, I've got different coefficient of friction. This is the dry contact, no oil. This is with oil. There's no change in steel and Teflon. But anyway, this is just for the information.